Hello, and welcome to this episode of Hannah waited last minute to do another project. Let's get into it. Now, what might this project be on, you ask? Well, glioblastoma! Woo! Cancer! But first, in order to understand what glioblastoma is, we have to ask the question, what is cancer? So the National Cancer Institute defines cancer as basically abnormal cell growth. And that's the sciencey definition, but I like to think of it as the cells just go boom and they don't want to work anymore. So cancer also has 5 categories: carcinomas, sarcomas, myelomas, leukemias, and lymphomas. But there are also lots of subcategories within those categories. So basically glioblastoma is a subcategory. That's what I'm trying to get at. So now we can get into what glioblastoma is. Glioblastoma is one of 120 different types of brain cancers. It has also gone by the name of glioblastoma multiforme and stage 4 astrocytoma. Not stage 4, grade 4, and grade 4 is the worst type. It's the worst because it's the most cancerous type of tumor, meaning it spreads the fastest and it's just really bad news. And it forms on the supportive tissue of the brain, also known as the glial cells. Glioblastoma can form in any part of the brain, however, the epicenters most commonly form in your frontal and temporal lobes. And while this cancer has genetic components, it is not genetically inherited. That just means just because your great-grandpa got it doesn't mean you're more likely to. My great-grandpa got it, that's why I'm doing the project on this. It's also important to note that this type of brain cancer, while it is a tumor, it's basically non-removable. How is it caused? We don't know. All we do know is that there is strong evidence against vocabulary, Miss Harrell. There is strong evidence against the hypothesis that a person's environment is what causes it, as in no direct links have been found. We sort of know that genetics play a part, but we don't know what part of the genetics, if that makes sense. Really, all we know is that glial cells freak out, and some gene in the glial cells cause it to freak out. We just don't know what. And I made this little infographic to discuss the signs and symptoms. So, since it's brain cancer, you might have a headache. You'll also have changes in your personality, definitely memory loss, possibly difficulty speaking, changes in your vision, weakness, nausea, and vomit. So how is glioblastoma diagnosed? Well, first, you have to identify your symptoms and then make a doctor's appointment. Then your doctor will go through their mental checklist of possibilities for illness, and once they think that you might have it, they will then order a CT scan or an MRI through a physical exam. But if your doctor goes through their mental checklist and then thinks it's severe enough, they might just go straight to a biopsy. Because this cancer is really fast growing, it metastasizes really quickly too, that's when they would do a biopsy. Biopsies are also used to confirm MRI and CT scan results. There is also the possibility of genetic testing, however, it's not very helpful. Now let's talk about the numbers. I would just like to preface this section and say it was really hard to find data and statistics, so I did my best, and so I don't know much about the statistics. I just know that the source I got them from is incredibly reliable. So, just to prove the reliability of my source, I did some research on them. This is the SEER data. That's where all this from. So SEER stands for Surveillance, Epidemiology, and End Results. And SEER is a part of the National Cancer Institute, and they just report on cancer diagnoses, studies, deaths, all the above. So because they are reporting on patients and cases, it is all population-based results. So what I discovered looking for statistics, people typically put together brain and nervous system cancers and they lump them into one category because there's just so few. So SEER estimates that around 23,000 new cases of brain and nervous system cancer are going to happen this year, and they also estimate that over 18,000 of those cases are going to pass away. It means that there is a 1.3% survival rate. And brain and nervous system cancers also account for 1.3% of cancers overall. So then this fun little diagram, the light green line shows the rate of new cases and the dark green line shows the rate of death, and they're pretty close. So take that for what you will.